Okay, here we go again. We got the organic mechanic and the undisputed hydro weight champion, Harley Smith.
Yay.
Undisputed.
Yay.
Yeah, yeah, no one can get past you. Champion forever.
Oh,
uh, hey, and a lot of our topics we've been discussing in the last episodes, we just had some questions come in. I thought maybe we could just build them together and just do a little Q&A. Um, I won't disclose any of the names or anything like that, so this will be fictitious. Um,
and
so, yeah. What was that, Harley?
I just said anonymous will protect their
Yeah,
anonymity.
that's right. That's right. So we'll start off this one. We'll call it Johnny in Rhode Island. Okay. Yeah. And Johnny wants to know, he said he's having salt buildup and salt problems in his indoor grow. He is in soil. And I know this can be an issue a lot of times it can happen in hydro too, just regular hydro and in soil. And so my first go-to reaction is take a look at your potassium source. Is it potassium chloride? Because that's a tremendous amount of salt. A lot of times over you know, adding too much potassium that's all salt based can be a bad thing. Very detrimental. And potassium nitrate has a pretty high salt index as well.
Hmm.
So anyway, the that was the question. Where's all the salt coming from, and what can I do to get rid of it? Do you have any thoughts, Harley?
Well, for outdoor, the first thing I look at for salt buildup is your irrigation water source. Is it should that really should be the first thing you test. Okay, do I have a good source, clean source of water? Because if you're watering and then you don't get really good runoff, it just over time it'll start to accumulate, especially if there's sodium chloride in your
Good
water.
point. Good point.
Um, and of course, good drainage along with that too. Make sure if you have a field, whatever you can do to improve drainage tiles, whatever, that will help leach out some of it. And there's some other things you can do to kind of protect from the salt. Like humic acids can help buffer that a little bit. It's
Hmm.
not the answer. Really, the answer has to start at the source. And even in hydroponics, a lot of times that's the last thing people check is the
Hmm.
water. That should be the first thing. A commercial grower, before they even build the greenhouse, if, are going to do a water test. Because if the water is not suitable, go someplace else. If it is if or you're gonna it's gonna cost you a lot of money to treat the water. So yeah, do a water test and then work from there. Would be my advice.
Okay. Okay. So let's say that's been in the equation. Water test has been done. It's showing good. They think they have a really good nutrient regimen going on. And let's say they are doing kind of a soil setup, an indoor soil setup. Look at the soil as well. That's been a common thing that all soils aren't created equal. And,
Right.
a lot of bagged prepared soil can have very, very strange items in that. Um, I know in the heyday, I don't know, 5 or 6 years ago, there was so much soil being consumed and so much soil being purchased that these manufacturers had a hard time keeping up with their product. So they
Mm,
were actually, chopping and grinding. I'm just going to call it foreign materials. I don't want to get
mm,
myself into trouble or anything. Then actually dyeing it. So some of the inputs were being manufactured so it looked like the soil, and it does happen. And I hate to say that, but the scramble for any kind of organic matter to turn into soil was out there, and so there was quite a few batches of really foul, bad soil. That's another thing you can check when this happens.
that's right. Yeah.
Right.
Yeah, I've seen it happen too, even with something that you'd expect to be very consistent, like a peat moss base growing medium. You think, okay, they're all going to be the same. They're not. And they do put a charge of nutrients in there too. in some of those bag
Yeah.
soils. And if the quality control isn't spot on, it's possible that they overdo it. And we've seen it. I've seen the peat based being high in salts right out of the bag. And the way you test it is soak it, do a run through, maybe squeeze some out, and just check your EC. If it's high, you've got a problem to start with. You're going to have to leach that material a long time before you're going to be able to plant into it.
Yeah, that's some good information. It goes back to that, yeah, when in doubt, flush it out, mentality. So always check all the parameters before you get started too, just to, those building blocks for success. Have a good plan going forward, and that is one thing that I guess we can recommend more is the simple checks, the water check, the soil check, all those things. If you want to be real successful and it's real controlled, you would want to do that.
Mhm.
Do
Yeah,
that.
it's always better to check before you do your planning and just going through a process than it is to try to solve a problem later when the plants are already there.
Right.
Makes it more really difficult to try to remediate many times.
That's right. That's right. And then, in a lot of outdoor situations or even in indoor soil situations, flushing may not be an option.
Right.
That oversaturation of water will probably do as much harm as the the high salts. Our go-to was always adding more humates and adding more humic acid just to
Oh,
kind of
that's what I thought.
help. It has a sequestering aspect of it. It's not going to get rid of the salt buildup, but it'll kind of bind it together to at least give the roots a chance to get some relief from that.
Hmm. Yeah, that's good. And also, though, you can do some soil tests even in the field. And sometimes it's not so matter of as much the amount of a single element, but the balance and how that affects other elements. And sometimes maybe you can't get rid of an element, which you'd like to do, but you could add something else to at least keep it in check
All
from
right,
doing
good
damage,
point.
more
Good
damage.
point. Well, hopefully, Johnny in Rhode Island, hopefully that'll help him out and uh, give him some ideas moving forward. And we got another interesting one that came in, and this topic doesn't come up very often. Uh, but let's just say Eric in Ohio. So Eric in Ohio asked, um, some of his fellow gardeners are telling him he has a sulfur deficiency. Very, very uncommon, a sulfur deficiency.
Oh,
And
yeah.
so, yeah, so his question was, how can where am I getting sulfur from in my nutrient regimen? And what's the best way to add sulfur to my regimen? Do you have any thoughts on that, Harley?
Oh, yeah. That's actually kind of an easy one. I mean, it's in hydroponics, the sulfur comes from magnesium sulfate, basically, for the most part. Because if you add enough magnesium to meet the needs of the plant, you're going to add more than enough sulfur just from that one source. Another way to do it would be potassium sulfate. You can do that if you want to try to reduce nitrogen, get rid of some of the um, potassium nitrate and replace it with potassium sulfate. But usually it's not a problem because just the magnesium alone, and no, that's in hydro. So you
Hmm.
could do the same thing. You could use your magnesium Epsom salt, magnesium sulfate. If you have a pH problem where the pH is way too high, you can literally add elemental sulfur too, because the microorganisms will break that down over time and change it into sulfuric acid, which will tend to lower the pH.
Okay,
So,
that's right. That's right. It's so based on what you're saying, it's possible this could not be a sulfur deficiency. It's possible it could be a magnesium deficiency then probably. Possibly.
if there
Kind of
wasn't enough
working in
magnesium
tandem.
sulfate,
Yeah.
um, yeah, magnesium you can provide. I kind of use two different forms in different formulas at different stages of growth. Sometimes I'll use magnesium nitrate
Hmm.
during veg because then if I want to keep my nitrogen on the high side. And if I'm using a lot of organics, sometimes those organics are fairly high in sulfur.
Yes,
Yeah. So if I
absolutely.
don't want a buildup of sulfur, especially if I'm going to do a recirculating system, because sulfur is taken up slowly by the plant compared to other nutrients. So it can tend to build up in the reservoir over time. So if I want to reduce the amount of sulfur I'm adding, then I'll use magnesium nitrate as a source, or like 50-50, have my magnesium sulfate in my part B
Mm,
and have magnesium nitrate in my part A.
that's a good point. That is a good point. I know a lot of manufacturers, other manufacturers out there, yeah, they prefer to use the magnesium nitrate in a lot of their liquid blends, just for formulation reasons and things
Hmm.
like that. So, yeah, that could lead to some sulfur deficiencies, I guess, if you were only using magnesium nitrate.
Probably. I'm
Yeah.
surprised though in soil that there's not enough sulfur already there. It's
Hmm.
possible. There's places though. There's parts of the
Hmm.
country where it's low. It used to be, you know where the sulfur used to come from?
The water.
Well, yeah, it used to come from the air. They used to have um, sulfur in the fumes, exhaust fumes, and then it would react with, or from industry, and it would react with the water, and it would have. Remember the acid rain? That was
Oh
sulfuric
yeah,
acid that was coming
yeah.
down. But it was a sulfur fertilizer for the plant, and the plant would even absorb some of it through the leaves. Of course, it would also damage the leaves. So there's a lot
Right.
more work, bad than good. But then once we started reducing pollution, some of the farms started realizing they had a deficiency of sulfur. But it's only in rare cases, I think. Most soils have
Right.
plenty of sulfur already.
Right. And a lot of pH down products out there, especially the liquid ones, is sulfuric acid based. So
Mhm.
you get a lot of sulfur from that. If you're using, a sulfur pH down, you'll get some sulfur from that. And anyway, on the topic of pH down, some of them are made with phosphoric acid. So
Mhm.
that could be a way you would be short in sulfur as well, I guess, possibly if you're using phosphoric acid to pH down. Anyway, just some unique questions that we don't hear very often. Thought it might be fun kind of
Yeah.
discussing.
I have a little story on that subject with the sulfuric acid. I remember one time I was visiting some greenhouses in Ohio, and I went into a lettuce greenhouse, and they were using NFT, nutrient film technique. They were growing in gutters, and I looked at the end of the gutters where there was a little bit of leakage, and you could see this buildup of crust. And I thought, wow, this is kind of crusty. What's going on? And then I looked at the ground, and it was all over the ground by the gutters, these chips of crust. I said, oh, wait a minute, that's got to be calcium sulfate. That's got to be gypsum that's building up. So, I just saw that while I was waiting for the owner, and then they came up and said, you're using sulfuric acid to for your pH down, aren't you? And she says, well, yes. How did you know? I can see the fallout. And then it turned out that it was recommended for her, but her water itself, she had a water. I said, can I see your water analysis? That's the first thing I'm going to look at, right? Look at the water. It was very high in sulfates to start with. So it had more sulfur in the raw water than what you would add in a fertilizer. It was already there. And then on top of that, they were using sulfuric acid to lower the pH. And then they were adding magnesium sulfate as their magnesium source, sulfur on top of sulfur on top of sulfur. And it was reacting with the calcium to make calcium sulfate. That's gypsum, 98% water insoluble. And she told me, well, that's what's going on. We did our nutrient analysis, and the sulfur was building up to over 1,000 parts per million in the
Wow.
nutrient itself. So she says, "What can I do?" I said, "Let me help you out here." So we made her a custom nutrient solution. We used the magnesium nitrate instead, right? instead of the magnesium sulfate, and she switched to nitric acid for pH down. Now, I wouldn't recommend that normally because it's dangerous. You got to take all the safety. You can't even breathe the fumes. But in her case, she had a chemistry background, lab background, so she knew how to handle it. Anyway, the long story short is when you add the sulfuric acid, it reacts with the calcium carbonate to make gypsum, and then it falls out of solution. When you add nitric acid, it burns off the bicarbonates as carbon dioxide and water, but then it reacts with the calcium to make calcium nitrate. You're actually changing the lime scale into fertilizer that's 98% water soluble. So when she made that change, we made a new nutrient that was in right balance for the water, and we switched the acid source. It was a huge turnaround. She was getting faster turnarounds time for growth and better quality just from making a couple small changes. So you really need to know what's in your water, and you need to be able to build your fertilizer around the water source as much as possible.
Once again, great advice. Was this a pretty large scale outfit?
Not super big. It's just a couple of bays, greenhouse bays. The problem that was bigger for them, and that was a big problem, but the other one was the heating costs in the winter. She would actually grow year round, and she would, because of the cost of fuel oil, she lost money in the winter. But so she was running at a loss, but she couldn't stop production because then she would lose her market. People go to some other source. So there was another issue to work with, and one of the ways I haven't talked to her about it, but one of the ways to move around there is to warm your nutrient solution, heat that. It's a lot cheaper to keep your nutrient flowing over the roots at a warmer temperature. About 75 degrees is ideal for the winter. Um, and maybe to add some amino acids because of the plant's taking up more calcium. Calcium pectate, it lowers the freezing temperature, and it also adds to the cold tolerance of the plant. So that was the other side of the issue. But as far as the nutrient was, it was excess sulfur.
Interesting. Huh. Wow, that is good advice. And that was in Ohio as well, you say?
hmm That was actually the
Huh.
same grower. Um, so she had two ends to the problem. One was nutrition, the other one was economic with heating.
Yeah, that's a big issue. It's expensive to produce heat. A lot of people, I've been to some projects very creative. One customer we had he had access to uh, oil, waste oil, and he ran it through some big boiler thing he made and blew it out through the greenhouse. Very unique, and it kind of cut his heating costs in the winter almost to zero. But yeah, that's a drawback to a lot of areas. You got to heat the greenhouse in the winter and cool it in the summer. So that can get very expensive, very trying too.
Yeah. I came really close at one point in my career as to stopping doing the R&D, and I was going to buy some land and do some hydroponic farming in Michigan. I was it's kind of funny, huh? But the way it was an area called Hillman, Michigan. They're kind of in the middle of nowhere, but they had a wood burning power plant for the city, and they were going to make a deal for an agricultural zone that right next to the power plant where they would literally pump the hot water from the cooling tanks, from the boilers. They would pump it, and we could have unlimited heat in the winter for the price of pumping water a short distance. And I went, wow, that's a major cost. If I could do some high tunnels, if I could use materials from Michigan instead of bringing in coconut fiber from the tropics, I could use something like river gravel and coarse sand as my substrate, and I could run water pipes through the sandbox to dissipate the heat and have a covering from a hoop, I could grow tropical herbs, Mediterranean herbs, all year long and be competitive with the Mediterranean because of the heat cost. I said, "Oh, I'm going to do this," and I was set up to buy it. I mean, I had everything going, getting ready to go, and at that time, though, Sue needed a job, and she applied for a teaching position, and she went out after she applied. She said, "I don't want to work for that principal for whatever reason, personal reasons," and I said, "Okay, let's not do it." So I would have been a rosemary farmer in northern Michigan. But here
Wow.
instead, I'm here talking to you today.
Oh boy. Well, I'm glad it went the other direction. We could have you here
Yeah.
for all this info. There's a out out here in the West where we're located. We're not far from Yellowstone National Park, and so
Mm,
there's a lot of hot water in the ground. And I've been to a couple greenhouses that actually use, the water coming out of the earth is, 100 plus degrees. And so they're able to grow all winter in their big tomato operation
mm,
all year round. It's phenomenal. What a great resource to have. And they started growing in the greenhouse way after the fact that they knew they had warm water. They kind of just seen an opportunity there and started doing that. So boy, and I always thought, how lucky would that be? How nice would that be? Just like your experience, like, wow, you could really do a lot of things in that
yeah.
situation. And then we have a sugar factory. There's a lot of sugar beets that are grown further to the west of us. They bring the beets in and process it and make sugar out of it. And during that process, they create a lot of hot water. And so they started growing tomatoes in greenhouses outside of the facility with that preheated water from the industry. And none of them really took off, in large scale like they wanted to, because once again, that's a lot of work for a side project, but the opportunity's there and it's neat to see them use that. Very interesting.
Yeah. In the Netherlands, they take it one step farther. They do the cogeneration for for heat, but they also will literally pump carbon dioxide from the power plants and from the factories, process it and pump it to the greenhouses. So they're capturing the carbon. You know about rock wool, right? You
Yeah.
know, it's made from
Yep.
basaltic rock, that's melted. Well, the main ingredient in the manufacture of rock wool is coke because they need to heat up and melt that rock. But they're Eco One in their factory because the gases, the carbon dioxide they're generating is pumped to the greenhouses in the area and recaptured. There's zero emissions. That's just again that's part of planning. Look at the whole picture from the manufacturing all the way to the final product and even disposal. If you can tie all those things together, you can be, very environmentally friendly in production. But cogeneration for electricity is and heat very, very common in the Netherlands.
Yeah, you never know what direction our little conversations take off, the turns and twists they take. I like it. All this stuff's fascinating and educational. Just good to have you aboard. How's the classes coming along?
Oh, that's a good. The classes are good. I'm more than halfway through the fall semester. Make a note of this, anyone out there watching this. The winter semester of the Master Grower Short course starts December 20th. Just about when the winter starts. I think it's the 21st. That's the winter solstice. Anyway, shortest day of the year. So it's December 20th, and enrollment is open now. So
Okay, sure
if
we'll
you
be
have
sure
access
to
to my
include that.
catalog, that you can start to sign up in advance.
Okay,
But
we'll
thanks for
include
asking.
that, and we'll put your website up, and we'll include that in our mailers again, and make a note of it here. December 20th. That's a good time of year. That's a good time of year just to be indoors and spend some time with the undisputed hydro weight champion. Harley Smith.
Yeah, and you get to learn a little more about indoor growing, but you also get a chance to plan for the spring. You start thinking how you want to set up your garden next year, what improvements you might want to make, take it to the next level. So the winter, I think, is a good time. The summer's kind of tough for me doing classes because people are so busy out
Uh-huh.
there in the field or in their gardens. But the winter, I think, might be a good one. December 20th, it starts.
Okay. We'll push some folks your direction that would love to be enlightened in that. Good time of year to do that.
I
Well,
appreciate it.
good. Once again, it's good spending time with you. Uh, we'll see what happens on our next visit next week. Anything
Okay.
else you need to add?
No, I don't think so. I think we covered some interesting topics today. Um, I think it's just to summarize, just make sure that you plan, do your soil analysis, do your do some kind of at least some basic testings of your soilless mixes, test your water before you get going, and then build your strategy around it. I think to me, that's the takeaway for today.
All right. Good advice as always. Next week, I'm going to be on the road.
Hmm.
I'm going to probably won't be available to visit with you. I'll be at some customers, do a little road trip here. So, but I'll keep you posted. I'm not sure
Okay.
exactly the dates, but I'll keep you in the loop. And until we meet again, uh, we'll see you next time.
Okay.
Yeah.
Talk to you later.
All
Bye.
right. Thanks, Harley. See ya.